So we know that isosceles triangle have at least one pair of congruent sides. That implies it has two congruent angles also. But we're going to look at more isosceles triangles and what you could find out about them. So if you drop a perpendicular from the vertex angle, that's the angle between the two congruent sides, drop it perpendicular. What's going to happen each time when you do that is that you're going to bisect the base. This side's going to be cut in half. Now, altitudes to triangle. All triangles, regardless of their shape, have three altitudes. Notice that if this is the shape it has, all the altitudes are on the inside, all three altitudes. For this one, it seems like it only has one, but what happened here is this is a right triangle. One of its altitudes is on the inside, in the interior. This side, the side of the triangle is in altitude, and this side of the triangle is already in altitude. So two of the altitudes are part of the triangle. This is an obtuse triangle. Notice that one of its altitudes is on the inside, and two of them are on the outside. When they're on the outside, you extend one of the sides of the triangle so it could meet the perpendicular segment. Extend, it meets the perpendicular segment. Now we're going to construct a perpendicular bisector segment, which means we're going to cut the segment in half, but with a perpendicular line or segment. So here's a given segment. So now you anchor your compass one time on the B and one time on the A. And then you rotate your compass and make this arc. Now anchor yourself on this A. Move your compass. Do the same thing on this side. Anchor yourself on the B. Anchor yourself on the A. Now you've created two intersections. All you have to do is join them, and you have this perpendicular bisector. The bisector is the one that does the cutting in half. So this is cutting this segment in half, and it's doing it perpendicularly. A circle is circumscribed. A circle is circumscribed about a triangle. That's hard to pronounce. All it means is that the triangle's inside the circle and the circle's around it. The circle is around the triangle, but it's around it in a special way. If we're going to say it's circumscribed, then the vertices, all the vertices of the triangle should be touching the circle. Notice right here, we can't say this triangle is circumscribed by the circle. Why? Because two of the vertices are not touching the circle. So this one doesn't qualify. This one does. Circumscribed. So what we're going to do here is give some more terms, and then we're going to do some construction. Okay, so we need some more terms. So notice the triangle is inside the circle, and the circle circumscribes the triangle. That means the triangle touches the circle at its vertices, with its vertices. If that's the case, then that center of that circle is called the circumcenter. And the radius of the circle is called the circumradius. So how do you construct it? How do you draw a circle around a triangle and make sure the circle touches the three vertices? How do you do that? Well, what you do is you find the center of the circle first. Don't try to draw the circle. It's going to be very difficult. Find the center of that circle. So how do you find it? Take two sides and find the perpendicular bisectors of two sides. So here's a perpendicular bisector of one side and a perpendicular bisector of the other side. Perpendicular bisectors, and when those two perpendicular bisectors intersect, that's going to be the center of the circle. The intersection is the center of the circle. All you have to do now is place your string or your compass right here. And the radius is going to be the segment that goes to the vertex. So just find one of these segments, which is the center, the radius, starting here at the center. Touch one of the vertices, and then just revolve, and you'll see you'll touch all the other ones also. Your compass will go through the whole circle. So again, notice that this is the center of that circle. And these are the radii of the circle. So if you were to anchor yourself here at the center, place the other side, put the spiky part of the compass here, and put the drawing side of the compass here, and just start drawing, it will follow where it's supposed to follow, and that circle will touch these three vertices. So here we have some facts. All triangles can be inscribed in a circle. So what we did, finding a circle that goes around the triangle and touches you the vertices, all triangles can have one of those circles. All triangles. Now, if you go to a convex quadrilateral, you could do the same thing. A quadrilateral has 4 sides. It's a polygon with 4 sides. You could circumscribe a circle about a quadrilateral if opposite angles are supplementary. Supplementary means that opposite angles add up to 180. If that's the case, you'll be able to find that circle that touches the 4 vertices of the quadrilateral. For kites, there's a requirement also. If you want to find a circumscribed circle about a kite, then those kites whose congruent angles are 90 degrees can be inscribed in a circle. So it only works for those type of kites. So right here, this is a practice problem. We're going back to the isosceles triangle. And you might say, well, how do you know this is an isosceles triangle if I don't see 2 congruent sides? Because since we have this segment going from a vertex to the opposite side perpendicularly, this would have to be a perpendicular bisector, right? So it broke this side of the triangle in half. That only happens if this triangle was isosceles, which means these 2 sides would have to be equal. For this to happen, these 2 sides would have to be equal. So now we know that 6x plus 15 should equal 12x minus 9. That's how we know they're equal. These represent the sides of the isosceles triangle. Then you do your algebra, solve for x, isolate your x by moving all the numbers away from it. So I'm gonna go ahead and bring this 6x to the other side by subtracting it. Here it is. Then I'm going to combine 12x minus 6x. These are going to stay here together, and this 9 is going to go to the other side by adding, right? So combine these two, you get a 24. Combine these two, you get a 6. Now divide both sides by 6. And x should equal 4 units. We have solved.